Good morning, fourth graders. Mr. Schroeder here. I just put out a division prodigy assignment the other day, and I got a few questions on it, so I feel like I should go through a little bit of a review on it, or at least the way I do it. I know your parents probably, or your grandparents taught you maybe a different way to divide, and that's just fine. You always got to do what works for you. The reason I'm going to have the goal of students will be able to divide using partial quotients is because when I teach division, I really want them to see how division works. I want you to see how division works as you're doing it. There might be ways that get it done quicker, but maybe don't teach you what division actually is. And I'm going to stress that as I go through this process. Before we get into it, I want to talk about the division symbols. The word divide could look like this. You've seen this one before, 12 divided by 3. You've seen maybe this one before, 12 divided by 3. So a slash and that mean the same thing. You've probably seen me do this one in class, 12 divided by 3. Some kids like to read that one backwards because it's written left to right. It's 3 divided by 12. No, it's 12 divided by 3 in this case. And then finally, the last one kind of looks like an improper fraction. 12 divided by 3. And all fractions are just division problems in disguise, especially improper fraction when the numerators above are bigger than the denominator, 12 divided by 3. Which we know the answer to this one is 4. But there's 4 different ways that you could write that. 4 different symbols for division. Now that we know that, I'm going to move on. When I think of division, I want to show you a physical example first before we jump into partial quotients. So this isn't quite partial quotients yet. For multiplication, I always write groups of, and you've heard me say that probably a million times this year. But for division, I like to write put in and then groups of. Put in groups of. Now if I read this number sentence, it says 12 put in groups of 3. I hope that starts clicking for you a little bit more, because when I think of 12 and putting them into groups of 3, I can actually physically see that almost. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's like having 12 apples and putting them into groups of 3, or putting them into bags or something of 3. Watch that. 3. Another bag of 3. 3. And 3. And as we all know, 12 divided by 3 is 4. I made 4 groups of 3. That sounds a lot like multiplication, doesn't it? Because division is just backwards. Now that I've gone that far, and you understand what division actually looks like, I'm going to start using this partial quotients with an easy problem like 12 divided by 3 at first, and then we'll work our way up into maybe 3-digit numbers divided by single-digit numbers by the end of this lesson. Okay, now that I've got here, once again this says 12 divided by 3. This is the symbol that I'm going to work with when I talk about partial quotients. My first step is to draw a line down. It's the same process putting these 12 apples into bags of 3, but now I'm just going to guess a little bit at how many 3s fit into 12. That's my first step. How many of these fit into this? How many 3s fit into 12? If I didn't know, we all know it's 4. But if I didn't know, let's just say I wanted to guess. Guessing is a great strategy in here because it helps you get closer to the real answer. I think 10 groups of 3 go into 12. 3, if I had 10 bags of 3 apples apiece, that would be 30. Does that work? Can I get rid of 30 apples from 12 apples? No, I can't. I got to go back and use a lower number of bags. How about 2? Well, that could work. 2 bags of 3 apples. If I started with 12 apples, if I did 2 bags of 3, that would get rid of 6 apples. And leaves me with 6 apples left. 2 bags of 3 apples. Got rid of 6. Now I have 6 apples left over. How many more bags should I use? Well, I just did 6. I just got rid of 6 by taking out 2 bags, so I'll take out 2 more bags of 3. And that will get rid of 6 more apples. 6 minus 6 is leaving me with Nothing. No remainder. No apples left over. So at the end, if I just count up the bags I took out, 2 plus 2 is 4. There's my answer. You guys knew that at the beginning, but you can see the process of partial quotients. 2 plus 2 is 4, so bang, bang, you got it done. There's two bags plus 2 more bags. I got rid of the amount of apples and left me with no apples at the end. I'm going to bump up the difficulty a little bit. You might be saying to yourself, Mr. Schroeder, that was a lot of work just to do 12 divided by 3. And I would agree with you. That's something you should know. That should be a fast fact. But let's just pretend this. 82. I'm working that same apple stand, and they gave me 82 apples, and I need to know how many bags to get to bag them up. And I'm putting them once again in bags of 3. A little bit more difficult here. 82 divided by 3. Same process, though. How many 3s do I think go into 82? This tends to be the hardest part because my wheels could sit here and spin forever, but the trick is just to start making a little bit of a guess. You want to get rid of a number of apples that's almost 82, so you don't have to do this over and over, because in theory, I could just go, I'll put them in one bag, that will get rid of 3 apples, and that leaves me with 79 apples, and then I'll get rid of another bag, and that gets rid of 3 more apples, and that will leave me with 76 apples. Man, that would take all day long. So I have to come up with a number on the side here that's going to get rid of a lot of apples, or the majority of my apples. Well, how about 10? 10 bags of 3 would be 30. Is that close to 82? No. I'll keep going. How about 20? If I took out 20 bags of 3 apples, 2 times 3 is 6. Add a 0. That'd be 60 apples. I just multiplied those together to get 60 apples that I've gotten rid of into bags. Now, that's a pretty good chunk of it, so now I can subtract my apples. There's no bigger bottom, so I don't have to borrow. And I still have 22 apples, but that's a lot less than 82, so now the problem is 22 divided by 3. How many bags of 3 could I make with 22 apples? Once again, just take a guess. I know I couldn't say 10 because that would be 30 apples. 3 times 10 is 30. That's a little bit too much, so it's going to be less than 10 now. Let's try 5. 5 groups of 3, or 3 groups of 5, it doesn't matter, is 15 apples that I've bagged. Now I have a bigger bottom, so I better borrow. Do all the borrowing first. Say that one time at home. Bigger bottom, better borrow, do all of the borrowing first. Then once I get to this point, I can subtract normal. 12 minus 5 is 7. 1 minus 1 is 0. I just keep doing the same process. I got rid of 15 apples by bagging 5 bags of 3. I have 7 apples left now. How many times is 3 fit into 7? That's something pretty easy. 3, 6, 9. I can't go all the way to 9, so I got to back up. Just 2 more bags will get rid of 6 apples. Hey, I'm down to 1 apple left. Can I make a full bag? Can 3 fit into 1? No. So that's called a remainder. It's something that's left over. I can't make another bag. But if I add up all the bags that I did make, 20, 25, 27, that's the whole amount of bags I made with a remainder of 1. This is a perfectly acceptable answer, but even better than that, you could write 27 and the remainder over the divisor of 3. 27 and 1/3 of a bag, because it would take 2 more thirds to make a full another bag. Either one of these 2 answers would be an awesome answer. I'm going to bump it up one more time, and then I'm going to give you an opportunity to try on your whiteboard. Okay? I'm going to make this one a little bit more difficult. And if you don't get to this point in one day, that's just fine. If you can do a 2-digit number divided by a 1-digit number by the end of this video, good for you. That's awesome. That's my goal for you. This one might be a little bit more advanced, but stay with me if you can. How about we have 873, and I'm going to divide that by 5. That's pretty big. That's longer division. And I obviously have to ask myself, How many 5s fit into 873? I'll make this into a real world problem for you. It's like I made a basketball camp and 873 kids showed up that day and I need to put them on teams of 5. How many teams am I going to have? Well, I'm going to have a lot of teams. Well, you can start making guesses. How about 100? Because 5 times 100 would get me 500. Is that a big chunk of 873? Yeah. If you would have actually said 5, or 10, and said that gets rid of 50 basketball players, making 10 teams of 5 gets rid of 50 basketball players, and subtracted that, did that get rid of a big chunk of the basketball players? Not really. So you're going to have to kind of estimate a little bit. One trick I like to use is I look at the front digit and say, can 5 fit into 8? And if it can't, I look at the front 2. But can 5 fit into 8? Yes. How many times? 1. I have to add 2 zeros to make up for my place value. 5 times 100 is 500. That's a big chunk. I'm going to stick with that for now. If there's any bigger bottoms, I got to borrow, but there's not in this case. So 3, 7, 3. Still have 373 basketball players to put on teams, but that's a lot less than what I started with. How many 5s fit into 373? I know it's less than 100 because that would be 500 again. Just try things. You know, you got to make estimations and then kind of whittle it down to what you think a good answer would be. 50. 5 times 5 is 25. Add a 0. That's a lot of basketball players, but I still feel like that might take me too much time. Let's try to bump it up and see if I can get even closer. How about 70? 5 times 7 is 35. Add a 0. That's a lot closer. So, I think I'll stick with that because it's going to get rid of a lot of basketball players. If I made 70 teams of 5, that gets rid of 350 basketball players, and it's going to leave me with, there's no bigger bottoms, 3, 2, 23 basketball players left. How many 5s fit into 23? That's a lot simpler question. 5, 10, 15, 20, 25 would be 5. So I can only do 4. 4 times 5 is 20. And I subtract, and it leaves me with 3 basketball players. I took out 4 teams of 5, and that got rid of 20 more players. And that leaves me with 3 basketball players. Can I have a whole nother team? Can 5 fit into 3? No, it can't. So I'm going to have to just add up the teams that I've made. I might want to put these 3 extra players on random teams and just have 3 groups of, or 3 teams that have 6. If I add up all the teams I have made, though, it's 4, 7, 1. I could make 174 teams and have a remainder of 3 kids. In reality, I would just put those kids on another team. But I could also write that as I have 174 full teams and 3, the remainder over the divisor, 3/5 of another team. So I know this got pretty long. The hardest part about division is making those good estimations as you go. I'll get rid of this for a second. Now on your whiteboard at home, if you have any questions, make sure you give me a email and I'll try my best to respond as soon as possible. But you could try things like this. If you're feeling like, you know what, Mr. Schroeder, I'm not totally understanding it, don't press it. You don't need to do triple digit divided by 1 digit. If you feel great, try 4 digits divided by 1 digit, or 1 digit. But in this case, if you're feeling like, Mr. Schroeder, I just need some help, maybe do some problems like this at first. How many 6s could go into 48 or 84? Draw your line down, solve the problem by taking out 10. How many 6s go into 24? It's an easier problem. 4. Because 4 groups of 6 make 24. 0. No remainder. The answer is 14. Stick to easier problems. That's what I'll suggest. If you feel like I'm killing it right now, I need to move up. On your whiteboard, give yourself some advanced problems. Maybe 593 divided by 7. What do I start with? I can't start with taking out 100 because that would be too much, and then work your way down with the same process. Once again, a lot of you are going to say, Mr. Schroeder, this seems like a lot of work. The number one reason I have you do partial quotients is to see the division as it's happening. Yes, it's okay to do your parents' way too. I love that. I'm glad you have a quick way of doing it. But a great math student should know multiple ways to get the same answer. Okay? You guys have a good weekend after you watch this video. Enjoy a little break from distance learning, and we'll see you on Monday, okay? Thanks, guys. Bye.